Hello, my name is Tapakorn, and I would like to suggest one development towards rescuing people. Over the years, there have been many news about people getting lost, with over 1,000 people getting lost in park each year. When this happens, volunteers would have to sign up and put themselves at risk. This is where drones come in. Drones are able to traverse in areas that an average human is unable to. They can also fly and survey a larger area than any human. I have designed a drone which I will call the RD Model 1, a design that contains ideas which could improve the current search and rescue drones. The RD Model 1 has an infrared camera and a GPS. The infrared camera will be able to find lost people by detecting heat and radiating from their bodies. The camera will also be able to switch to a normal camera to survey the area. The GPS is used to pinpoint the lost person's location and to find the drone in case it also gets lost. The drone will be able to fly at the altitude of 5,000 kilometers and has a range of 15 kilometers. The first problem this drone is tackling will be flight time. Since every minute counts during a search and rescue operation, drones having to return to base can cause crucial time during which the lost may depend on for their survival. A solution to this could be switching from using lithium-ion batteries, which are typically used in drones, to LiPo batteries, which have more voltage in its output and are lighter. This design will be tested by using a weighing scale and a voltmeter to measure the voltage output of the drone. In order to extend the time even further, we can use internal hot swapping systems, which will quickly and automatically switch the battery once the first battery power gets low. A method for this is for the drone to slowly descend onto the ground and using a motor to move the battery out and a new battery in. This is similar to how the revolver cylinder works. This means no stations will be needed for the drone to change batteries. Another problem with search and rescue drones with this design will solve is the weather. Thailand's weather is windy and it rains often. The RD Model 1 could use the GPS and implement barometers, which help stabilize the drone during turbulence, and it can also be made waterproof by coating it with a layer of silicone conformal coating. The last issue during a search and rescue mission is the time that rescuers take to help the lost people. I suggest adding a supply box which can be attached onto the drone using a hook, which can be lowered down onto the ground using a motor. This would give the rescue team more time to save the lost person. The box will contain items such as food, water, and medkits, which could help the missing person survive. In order to carry this, the drone needs to have a high thrust force. When designing the drone, I believe that we should follow the 2-to-1 rule, where the drone has to produce a thrust force which is double the weight of the drone. In conclusion, the RD model is designed to improve upon the current search and rescue drones. The drone design comes equipped with an infrared camera to search for the lost person, and is able to switch into a normal camera to survey the area. A supply box to carry items could help the missing person, and a GPS to find the location of the missing person. It can also stabilize itself during turbulence and is waterproof. The specifications include LiPo batteries and a hot swap system to increase the flight time. I believe that these ideas can dramatically improve the effectiveness of search and rescue drones.